July 28, 1943, 22,000 feet above Schweinfurt, Germany. The morning sun cuts through scattered clouds like molten silver, casting long shadows across the industrial landscape below. In the cockpit of his Focke-Wulf 190, Hauptmann Ernst Richter adjusts his oxygen mask and scans the horizon with the practiced eye of a veteran fighter pilot. The rhythmic drone of his BMW 801 radial engine provides a steady backdrop to his thoughts as he leads his staffel through the crisp morning air. Below, the ball-bearing factories of Schweinfurt continue their vital work for the Reich, unaware that today will mark a turning point in the aerial war over Europe. Richter's radio crackles with the familiar voice of his wingman, Lieutenant Klaus Weber. Dick Otto's approaching from the west, Weber reports, using the Luftwaffe's derisive nickname for American heavy bombers. Through his canopy, Richter spots them, a formation of B-17 flying fortresses, their silver fuselages glinting like metal insects against the blue sky. But something else catches his attention. Unfamiliar shapes moving in a wide protective screen around the bombers. These aircraft appear larger and more robust than the nimble P-51 Mustangs or the graceful P-38 Lightnings the Luftwaffe has grown to respect and fear. What are those fat machines? Weber's voice carries a note of amused confusion. The new fighters appear almost comically oversized, their enormous radial engines giving them a bulbous, ungainly appearance that seems to violate every principle of aerodynamic efficiency Richter learned in flight school. Their broad wings and thick fuselages make them look more like flying bathtubs than instruments of aerial warfare. As the formations converge, Richter feels a familiar surge of confidence. After shooting down 23 Allied aircraft, including 12 American fighters, he has learned to read the capabilities of enemy machines at a glance. These new arrivals, whatever they are, look like easy prey. The scene unfolding at 22,000 feet represents more than a routine fighter engagement. It embodies the collision of two fundamentally different approaches to aerial combat, two distinct philosophies of industrial warfare, and two competing visions of how democratic abundance could be translated into military effectiveness. The ungainly fighters approaching Schweinfurt are Republic P-47 Thunderbolts, the heaviest single-engine fighters ever built, carrying more firepower than most medium bombers and representing American industrial might in its most concentrated form. For nearly 4 years, the Luftwaffe had dominated European skies through superior training, tactical innovation, and aircraft specifically designed for agility and climbing performance. German fighter doctrine emphasized individual pilot skill, energy management, and the principle of engaging only when conditions favored the German aircraft. Pilots like Richter had been trained to exploit every advantage, altitude, surprise, aircraft performance, and tactical positioning, to achieve maximum results with minimum risk. This approach had proven devastatingly effective against the Royal Air Force during the Battle of Britain and against Soviet forces on the Eastern Front. The German aircraft industry had responded to these tactical requirements by producing fighters that prioritized specific performance characteristics over raw power. The Messerschmitt Bf 109, backbone of the Luftwaffe fighter force, weighed less than 7,000 pounds and could climb to altitude faster than any Allied fighter. The newer Focke-Wulf 190 that Richter pilots combines this climbing ability with superior roll rate and diving speed, making it nearly impossible for Allied fighters to engage on equal terms. German pilots had learned to use these advantages ruthlessly, making high-speed slashing attacks against Allied formations before climbing away beyond the reach of defensive fire. American fighter development had followed a markedly different path, driven by the unique requirements of long-range escort missions over occupied Europe. The P-47 Thunderbolt that Weber dismisses as a fat machine weighs nearly 15,000 pounds when fully loaded, more than twice the weight of a typical German fighter. This massive weight carries a specific purpose. The Thunderbolt mounts 8 50-caliber machine guns with 400 rounds of ammunition, more firepower than any single-engine fighter in history. While German aircraft carry 2 or 4 guns with limited ammunition, the P-47 can sustain continuous fire for over a minute, delivering a weight of fire that can destroy any aircraft it hits. The philosophical difference extends beyond mere specifications to encompass fundamentally different concepts of aerial warfare. German doctrine treats fighter combat as a skilled craft requiring years of training, individual excellence, and careful resource management. Each Luftwaffe pilot represents a massive investment in training and experience that cannot be quickly replaced. German aircraft are designed to maximize the effectiveness of these highly trained pilots, providing superior performance characteristics that allow skilled aviators to engage and disengage at will. American doctrine, by contrast, treats aerial combat as an industrial process that can be systematized, standardized, and scaled to unprecedented levels. The P-47 reflects this philosophy by providing novice pilots with overwhelming firepower that compensates for lack of experience. Where German pilots must achieve precise deflection shots with limited ammunition, American pilots can simply point their aircraft at the enemy and pull the trigger, knowing that their massive ammunition load will eventually find its target. This democratization of aerial combat allows the United States to rapidly train large numbers of competent fighter pilots rather than a small elite of aces. The industrial implications of these competing approaches become apparent when examining production figures. Germany produced approximately 12 Focke-Wulf 190s during the entire war, each one carefully crafted to exacting standards by skilled workers using increasingly scarce materials. The United States manufactured over 15 P-47 Thunderbolts in less than 4 years, using mass production techniques that allowed relatively unskilled workers to assemble complex aircraft with unprecedented speed and efficiency. While German pilots learned to husband their ammunition and engage only when victory seemed certain, American pilots could afford to fire speculatively, knowing that their aircraft carried enough ammunition for multiple engagements. This abundance extends beyond mere numbers to encompass every aspect of American fighter operations. German pilots often flew multiple missions per day in aircraft that received minimal maintenance due to parts shortages and overworked ground crews. American squadrons operated under strict maintenance schedules that ensured each aircraft received thorough inspection and repair between missions. German pilots learned to accept mechanical failures as routine hazards of aerial combat, while American aviators expected their machines to function reliably under the most demanding conditions. The radial engine that gives the P-47 its distinctive appearance represents perhaps the starkest contrast between German and American approaches to fighter design. German engineers preferred inline engines like those used in the Bf-109 and Fw-190, which provided better aerodynamic efficiency and reduced frontal area. The Pratt & Whitney R2800 that powers the Thunderbolt produces 2,000 horsepower, nearly twice the output of typical German fighter engines, but creates enormous drag that reduces top speed and maneuverability. American designers accepted this trade-off because the massive engine provides advantages that German fighters cannot match. The R2800's 18 cylinders can absorb tremendous battle damage and continue operating, while the complex liquid-cooled engines preferred by German designers become vulnerable to any hit that damages cooling systems or coolant lines. The radial engine's air cooling eliminates vulnerable radiators and coolant systems, allowing P-47 to sustain damage that would down any German fighter. More importantly, the engine's massive power output enables the P-47 to carry external fuel tanks that extend its range far beyond anything German fighters can achieve. While Luftwaffe interceptors must operate within a few hundred miles of their bases, P-47 can escort bomber formations deep into German territory and still retain enough fuel for extended combat. This range advantage transforms the strategic balance of the air war by denying German fighters the sanctuary of distance that had previously protected their aircraft industry and training facilities. As Richter's formation approaches the American bombers, he implements the standard Luftwaffe tactical doctrine that has proven so effective against previous Allied escort fighters. His 4 Focke-Wulf 190s climb to gain altitude advantage, while staying beyond the range of the bombers' defensive guns. Once positioned above and behind the enemy formation, they will make high-speed diving attacks designed to scatter the escort fighters and create opportunities for follow-up attacks against the vulnerable bombers. The tactic has worked repeatedly against P-38 Lightnings and Erle-model Spitfires, which lack the performance to maintain formation integrity under attack. Richter expects the bulky American fighters to prove even more vulnerable to slashing attacks that exploit their apparent lack of maneuverability. His combat experience suggests that heavily loaded fighters cannot match the climbing performance and turning ability needed for effective aerial combat, making them easy targets for properly executed hit-and-run attacks. The P-47s approaching Schweinfurt carry a secret that German intelligence has not yet discovered. These aircraft represent the latest evolution in American fighter design, incorporating lessons learned from 2 years of combat over Europe. The massive radial engine that makes them appear ungainly actually provides power-to-weight ratios superior to most German fighters, while their robust construction allows them to dive at speeds that would tear apart lighter aircraft. Most importantly, their pilots have been trained in tactical formations, specifically designed to exploit the Thunderbolt's unique characteristics. Major Francis Gabreski, leading the 56th Fighter Group's escort mission, understands that his P-47s cannot match German fighters in traditional turning combat or climbing duels. Instead, he has drilled his pilots in tactics that emphasize the Thunderbolt's superior diving performance, massive firepower, and ability to absorb battle damage. Rather than attempting to dogfight with German interceptors, his squadrons will use altitude and speed to make devastating firing passes before using their superior power-to-weight ratio to climb away from retaliation. The 8 50 caliber machine guns mounted in each P-47's wings represent the culmination of American small arms development and mass production capabilities. Each gun fires 750 rounds per minute, creating a combined rate of fire exceeding 6,000 rounds per minute when all 8 guns operate simultaneously. The ammunition load of 425 rounds per gun provides enough firepower for sustained combat that would exhaust the ammunition supply of 3 German fighters. More significantly, the 50 caliber projectiles themselves embody American industrial advantages that German pilots have not yet experienced. Each round weighs nearly twice as much as the 20 cannon shells used by Luftwaffe fighters, carrying sufficient kinetic energy to penetrate engine blocks and structural components that would deflect lighter projectiles. The armor-piercing incendiary rounds carried by P-47 can ignite fuel tanks and destroy vital aircraft systems with single hits, while the tracer rounds allow pilots to observe their fire and adjust their aim in real time. American ammunition production capabilities ensure that P-47 pilots never face the shortages that increasingly plague Luftwaffe operations. German pilots have learned to fire short bursts to conserve ammunition, often breaking off promising attacks when their limited supply runs low. American fighters carry enough ammunition to sustain fire for over a minute of continuous shooting, allowing pilots to fire longer bursts that guarantee target destruction once hits are achieved. The radio equipment installed in each P-47 provides another crucial advantage that German pilots have not yet learned to appreciate. While Luftwaffe fighters rely on basic radio systems that often fail under combat stress, American aircraft carry sophisticated VHF radios that maintain clear communication throughout extended missions. This communication capability allows P-47 formations to coordinate attacks, share tactical information, and concentrate firepower against specific targets with unprecedented precision. As Richter positions his staffel for their initial attack, he observes the American formation with growing puzzlement. Rather than maintaining the loose defensive formations typical of earlier Allied escorts, the P-47 fly in tight tactical groups that seem designed to provide mutual fire support. Each 4-aircraft flight maintains precise spacing that allows overlapping fields of fire while preventing German fighters from isolating individual targets. The formation discipline suggests a level of training and tactical sophistication that contradicts the ungainly appearance of the aircraft themselves. The lead P-47 begin a slight climbing turn that brings them into position to intercept Richter's diving attack. This maneuver surprises the German pilot, who expected the heavily loaded fighters to lack the performance for aggressive tactical maneuvering. The American aircraft appear to climb as effectively as his Focke-Wulf 190, despite their obvious weight disadvantage. More ominously, the P-47s maintain perfect formation integrity throughout the climb, suggesting that their pilots possess both the skill and aircraft performance needed for coordinated combat maneuvering. Richter commits to his attack despite these warning signs, confident that his superior altitude and diving speed will overcome any performance advantages the American fighters might possess. He rolls into a steep dive that brings his staffel down on the P-47 formation at over 400 miles per hour, intending to scatter the escort fighters with a high-speed firing pass before climbing away for a second attack. The tactic has proven effective dozens of times against Allied fighters that lack the performance to counter German hit-and-run attacks. The engagement that follows will shatter every assumption about aerial combat that Richter has developed during his successful career as a fighter pilot. As his Focke-Wulf 190 approaches firing range, the lead P-47 turns directly toward his attack, presenting a head-on engagement that no Allied fighter has previously attempted against diving German fighters. The maneuver violates every principle of defensive fighter tactics that Richter learned in training, where lighter aircraft should always avoid head-on attacks against heavier, more powerfully armed opponents. The sight picture in Richter's gun sight shows the P-47 growing rapidly larger as the two fighters approach each other at a combined closing speed exceeding 700 miles per hour. At 800 yards range, he opens fire with his four 20mm cannons and two machine guns, expecting to see the American fighter disintegrate under the impact of high-explosive shells. Instead, the P-47 continues its approach, while tracer rounds from its 8 machine guns create a cone of fire that seems to fill Richter's entire field of vision. The psychological impact of facing 8 50 caliber machine guns in head-on combat cannot be overstated. Where German fighters typically mount 2 or 4 guns that fire relatively slowly, the P-47's battery creates a visual display of tracer fire that appears overwhelming even to experienced combat pilots. The continuous stream of heavy machine gun bullets creates sound and vibration effects that penetrate aircraft structures and reach pilots' consciousness even through helmet and oxygen mask. For pilots accustomed to the surgical precision of limited ammunition dogfighting, the P-47's massive firepower represents a fundamentally different approach to aerial combat. At 400 yards, Richter's 20mm shells begin striking the P-47's engine cowling and wing roots, hits that should cause immediate structural failure or engine shutdown. Instead, the American fighter maintains perfect course and continues firing, its tracers now passing uncomfortably close to Richter's canopy. The Focke-Wulf 190 pilot begins to understand that he faces an aircraft designed to absorb battle damage that would destroy any German fighter, while delivering firepower that no Luftwaffe pilot has previously experienced. The radial engine that makes the P-47 appear ungainly proves its worth under combat conditions. The R-2800 18 cylinders continue operating even after several 20mm hits, while the engine's massive construction absorbs projectile impacts that would disable smaller power plants. More importantly, the engine's air cooling system eliminates the vulnerable radiators and coolant lines that make German fighters susceptible to single hits that cause rapid overheating and engine failure. At 200 yards, the P-47's 8 machine guns achieve devastating effect on Richter's aircraft. The 50 caliber projectiles punch through the Focke-Wulf's lightweight construction with ease, severing control cables, puncturing fuel lines, and creating structural damage that immediately affects the aircraft's handling characteristics. The armor-piercing incendiary rounds ignite hydraulic fluid and create small fires that spread rapidly through the fighter's internal systems. Richter finds his aircraft becoming increasingly difficult to control as 50 caliber rounds destroy vital components throughout the airframe. The Focke-Wulf 190 excellent roll rate disappears as damaged ailerons respond sluggishly to control inputs. Engine power fluctuates as bullets damage ignition systems and fuel delivery components. Most alarming, smoke begins entering the cockpit as fires spread through areas that should be protected by armor plating. The engagement lasts less than 3 seconds, but its outcome revolutionizes Richter's understanding of aerial combat capabilities. As the two fighters flash past each other, he realizes that his supposedly superior aircraft has been systematically destroyed by an opponent he initially dismissed as inferior. The P-47's combination of massive firepower, robust construction, and adequate performance has overwhelmed tactical advantages that German fighters had previously enjoyed against all Allied opposition. Richter's wingman, Lieutenant Weber, attempts to assist by attacking the P-47 from the side, hoping to exploit the American fighter's apparent lack of maneuverability in turning combat. This attack brings Weber within range of the P-47's wing-mounted machine guns, which traverse to engage the new threat, while the aircraft maintains its original flight path. The sight of 8 gun barrels swinging toward his aircraft creates an immediate psychological impact that affects Weber's attack accuracy and tactical decision-making. The P-47's pilot, Second Lieutenant Robert Johnson, demonstrates the tactical training that American fighter pilots receive to maximize their aircraft's unique capabilities. Rather than attempting to turn with the more maneuverable German fighter, Johnson uses his superior power and diving performance to extend away from Weber's attack, while maintaining continuous fire from his rear-facing guns. This tactic prevents the German pilot from achieving a stable firing position, while exposing him to defensive fire that increases in accuracy as the range decreases. Weber's attack illustrates the limitations of traditional European fighter tactics when applied against aircraft designed for different combat conditions. His Focke-Wulf 190 can outturn the P-47 in sustained maneuvering, but this advantage becomes irrelevant when the American fighter refuses to engage in turning combat. Instead, Johnson uses altitude changes and speed variations to maintain separation, while keeping his guns trained on the pursuing German aircraft. The .50 caliber ammunition that Johnson fires represents years of American research into optimal projectile design for aerial combat. Each round carries twice the kinetic energy of typical fighter ammunition, ensuring penetration of armor plating and structural components that would deflect lighter projectiles. The incendiary component ignites fuel and hydraulic systems on impact, while the tracer element allows precise fire correction even during high-speed maneuvering. Weber's attack run brings him within effective range of Johnson's defensive fire for nearly 10 seconds, an eternity in aerial combat where engagement durations typically measure in fractions of seconds. During this period, the P-47's 8 machine guns fire over 1,000 rounds, creating a cone of projectiles that makes evasion nearly impossible. The sheer volume of fire compensates for the difficulty of achieving precise aim during violent maneuvering, ensuring that some percentage of rounds will find their target regardless of defensive actions. The psychological effect on Weber proves as devastating as the physical damage to his aircraft. German pilots have learned to expect brief, surgical engagements where victory or defeat depends on precise gunnery and tactical positioning. The P-47's ability to sustain continuous fire while maneuvering defensively creates a combat environment unlike anything in Weber's experience. Instead of the familiar pattern of attack, brief firing opportunity, and disengagement, he faces sustained defensive fire that continues throughout his entire attack run. Weber's Focke-Wulf 190 begins showing battle damage after 5 seconds of exposure to .50 caliber fire. Hits on the engine cowling cause immediate power loss, as projectiles damage cylinders and ignition systems. Strikes on the wing roots weaken structural components and affect control surface response. Most seriously, armor-piercing rounds penetrate the fighter's fuel system, creating vapor leaks that pose immediate fire hazards. The German pilot finds himself in an impossible tactical situation. Continuing his attack exposes him to increasingly accurate defensive fire that will inevitably destroy his aircraft. Breaking off the attack, however, means abandoning his leader and allowing the American bombers to continue their mission without effective opposition. The dilemma illustrates how the P-47's massive firepower has fundamentally altered the tactical calculus of aerial interception missions. Weber chooses to break off his attack, pulling his damaged Focke-Wulf into a steep climb designed to exploit his aircraft's theoretically superior climbing performance. This maneuver should carry him beyond the range of the P-47's defensive fire, while positioning him for a second attack from a more advantageous angle. Instead, he discovers that Johnson's Thunderbolt can match his climb rate while continuing to fire, extending the engagement far beyond typical parameters. The P-47's ability to climb while maintaining accurate fire represents a fundamental advance in fighter aircraft design. Previous Allied fighters lacked sufficient power to climb steeply while maneuvering defensively, forcing them to choose between altitude advantage and defensive capability. The Thunderbolt's massive engine provides power for both climbing and maneuvering simultaneously, eliminating tactical compromises that German pilots have learned to exploit. Johnson's pursuit of Weber's climbing Focke-Wulf demonstrates the psychological transformation that occurs when pilots realize they possess overwhelming firepower advantages. Rather than breaking off the engagement to rejoin his formation, Johnson continues firing at the retreating German fighter, determined to achieve a definitive victory that will eliminate future threats to the bomber formation. This aggressive mindset reflects confidence in his aircraft's capabilities and ammunition supply. The extended firing sequence allows Johnson to observe the effects of 50 caliber projectiles on German aircraft construction. Each hit creates visible damage that affects the target's performance and handling characteristics. Strikes on control surfaces reduce maneuverability. Engine hits cause power loss and overheating. Fuselage penetrations create structural weakening that affects high-speed maneuvering. The cumulative effect builds rapidly as the P-47 sustained fire creates multiple damage points simultaneously. Weber's aircraft suffers engine failure after absorbing over 250 caliber rounds during the extended engagement. The Focke-Wulf 190 BMW 801 radial engine, designed for reliability and ease of maintenance, cannot withstand the kinetic energy of repeated heavy projectile impacts. Cylinder damage reduces power output, while ignition system failures cause irregular operation. Cooling system damage leads to rapid overheating that threatens complete engine seizure. The German pilot attempts an emergency landing at a nearby airfield, hoping to save both his aircraft and his life. This decision reflects the German Air Force's desperate need to preserve experienced pilots and combat aircraft, as attrition takes its toll on operational strength. Every lost pilot represents training and experience that cannot be quickly replaced, while each destroyed aircraft reduces the Luftwaffe's already inadequate interceptor strength. Weber's forced landing succeeds, but his aircraft suffers damage that will require weeks of repair work using increasingly scarce spare parts and materials. The Focke-Wulf 190 airframe shows over 30 separate bullet holes, while the engine requires complete replacement due to internal damage from 50 caliber projectiles. More significantly, Weber himself suffers psychological trauma from his encounter with American firepower that will affect his future combat effectiveness. Meanwhile, Richter struggles to maintain control of his battle-damaged aircraft while dealing with the immediate consequences of his head-on encounter with Johnson's P-47. The Focke-Wulf 190 control systems have been severely compromised by 50 caliber hits that severed cables and damaged hydraulic lines. The aircraft responds unpredictably to control inputs, making precise maneuvering impossible and threatening complete loss of control. Smoke continues to enter Richter's cockpit from fires burning in areas that should be protected by armor plating. The 50 caliber armor-piercing projectiles have penetrated defensive systems designed to stop smaller caliber ammunition, creating vulnerabilities that German aircraft designers never anticipated. The fires spread rapidly through fuel and hydraulic systems, creating immediate threats to pilot survival. Richter's combat experience allows him to recognize that his aircraft has suffered fatal damage that will prevent successful return to base. The control system failures make normal landing procedures impossible, while the spreading fires threaten explosion or structural failure at any moment. His only viable option is immediate bailout over friendly territory, accepting the loss of both aircraft and mission in exchange for pilot survival. The German pilot's decision to abandon his aircraft represents more than personal survival. It symbolizes the broader failure of Luftwaffe interception tactics against American heavy bomber formations. Each lost interceptor reduces German defensive capabilities, while each surviving American bomber delivers its payload to vital industrial targets. The mathematical relationship between attacker and defender has shifted decisively in favor of Allied air operations. Richter's bailout occurs at 18,000 feet altitude, providing adequate time for parachute deployment and descent to German-controlled territory. His survival ensures that German intelligence will receive first-hand reports about American fighter capabilities. But this information comes too late to influence aircraft design or tactical doctrine. The industrial and training advantages that created the P-47 cannot be matched by German resources already stretched to the breaking point. The parachute descent gives Richter time to contemplate the implications of his encounter with American firepower. The P-47 that destroyed his aircraft represents a fundamentally different approach to aerial warfare, one that emphasizes overwhelming firepower over precision gunnery robust construction over lightweight agility, and mass production over individual craftsmanship. These characteristics reflect American industrial capabilities that Germany cannot match given its resource limitations and strategic situation. During his descent, Richter observes the continuing air battle as additional P-47s engage the remaining aircraft from his staffel. The American fighters demonstrate tactical coordination and mutual support that maximizes their firepower advantages while minimizing exposure to German countermeasures, rather than engaging in individual dogfights that favor German aircraft characteristics. The P-47s maintain formation integrity while concentrating their combined firepower against isolated targets. The sight of 8 50-caliber machine guns firing simultaneously creates visual and psychological effects that transcend their physical destructive capability. The massive muzzle flashes and tracer streams appear overwhelming even to experienced combat pilots, while the sound of 6,000 rounds per minute creates audio pressure that penetrates aircraft structures and affects pilot concentration. German pilots accustomed to the precise, economical gunnery required by limited ammunition supplies find themselves psychologically unprepared for the sensory assault of American mass firepower. Richter's remaining pilots attempt various tactical responses to the P-47 threat, but each approach reveals additional American advantages. Diving attacks that should exploit German speed advantages are countered by P-47 that can match or exceed their diving performance while delivering devastating defensive fire. Climbing attacks designed to use altitude advantage are met by Thunderbolts, whose massive engines provide power for both climb and combat maneuvering. Turning engagements that favor German aircraft characteristics are avoided by American pilots trained to use their firepower and durability advantages. The tactical stalemate that develops illustrates how the P-47's characteristics have invalidated traditional fighter combat doctrine. German pilots can no longer rely on superior aircraft performance to achieve favorable engagement conditions, while American pilots need not possess exceptional flying skills to achieve victory through overwhelming firepower. The democratization of aerial combat effectiveness allows the United States to field large numbers of competent fighter pilots rather than small numbers of elite aces. As Richter lands in a farm field near Schweinfurt, he can hear the continuing sound of aerial combat as P-47s press their attacks against the remaining German interceptors. The sustained firing indicates that American pilots are not constrained by ammunition limitations that force German pilots to break off promising attacks. This abundance of firepower extends engagement durations and increases the probability of achieving definitive victories rather than inconclusive encounters. Local German civilians who assist Richter's recovery provide additional perspective on the changing nature of the air war. They report increasing frequency of American bomber formations, protected by fighters capable of engaging German interceptors on equal or superior terms. The psychological effect on civilian morale becomes significant as the population realizes that Luftwaffe fighters can no longer guarantee protection against Allied bombing attacks. Intelligence officers who debrief Richter struggle to comprehend his reports about American fighter capabilities. The P-47's combination of massive firepower, robust construction, and adequate performance challenges fundamental assumptions about optimal fighter design that have guided German aircraft development. The concept of using brute force rather than precision engineering to achieve air superiority contradicts European military traditions and tactical doctrine. Richter's detailed description of the P-47's 8-gun armament initially meets with skepticism from intelligence analysts who consider such firepower unnecessary for effective aerial combat. German experience suggests that 2 or 4 guns provide adequate destructive capability when properly aimed, making the American approach appear wasteful and inefficient. Only gradually do intelligence officers recognize that massive firepower compensates for the tactical and training limitations of rapidly trained pilots. The industrial implications of American fighter production become apparent when intelligence estimates suggest that the United States can manufacture P-47s faster than Germany can train replacement pilots. The mathematical relationship between production capacity and training requirements favors nations with abundant industrial resources and training facilities. Germany's limited capacity for both aircraft production and pilot training cannot match American capabilities in either category. Technical analysis of 50 caliber projectiles recovered from Richter's aircraft reveals the sophisticated metallurgy and manufacturing techniques used in American ammunition production. Each round represents precision manufacturing capabilities that ensure consistent ballistic performance and reliability under combat conditions. The armor-piercing cores use materials and heat treatment processes that German industry cannot duplicate given wartime resource constraints and production priorities. The incendiary components of American ammunition demonstrate advances in chemical engineering that enhance projectile effectiveness against aircraft targets. The compounds ignite reliably upon impact while generating sufficient heat to ignite fuel vapors and hydraulic fluids. German intelligence recognizes that these technical advances result from extensive research and development programs that require resources and institutional capabilities beyond German capacity. Richter's testimony about P-47 radio communication capabilities reveals another American advantage that German intelligence had not previously identified. The sophisticated VHF radios installed in American fighters enable tactical coordination and mutual support that maximizes formation effectiveness while minimizing individual aircraft vulnerability. German radio equipment often fails under combat stress, limiting tactical flexibility and reducing situational awareness. The psychological impact of Richter's encounter extends beyond individual pilot morale to affect broader Luftwaffe confidence in their aircraft and tactics. Pilots who previously considered German fighters superior to all Allied opposition must now acknowledge that American aircraft possess specific advantages that can overcome traditional German strengths. This recognition undermines the aggressive confidence essential for effective fighter operations. Flight training programs within the Luftwaffe begin incorporating warnings about American fighter capabilities. But these modifications cannot address the fundamental resource limitations that prevent Germany from matching American aircraft production or pilot training capacity. Tactical modifications that emphasize hit-and-run attacks require fuel supplies for extended operations that are increasingly unavailable due to petroleum shortages and transportation difficulties. The broader strategic implications of American fighter effectiveness become apparent as bomber formations penetrate deeper into German territory, with reduced losses to interceptor attacks. Industrial targets that were previously protected by distance and Luftwaffe opposition now face systematic destruction that affects German war production capacity. The ball-bearing factories at Schweinfurt, which Richter was attempting to defend, suffer severe damage that reduces production of critical components needed for aircraft and vehicle manufacturing. German aircraft designers study intelligence reports about P-47 characteristics in attempting to develop countermeasures, but their efforts are constrained by material shortages and production priorities. The aluminum, steel, and specialized alloys required for advanced fighter construction are increasingly diverted to other military programs or simply unavailable due to raw material shortages. Even optimal designs cannot be manufactured without adequate industrial resources. Attempts to increase German fighter armament to match American firepower levels encounter multiple technical and logistical obstacles. Heavier guns require structural modifications that affect aircraft performance, while increased ammunition loads reduce fuel capacity and operational range. More fundamentally, German ammunition production cannot support the high consumption rates that make American mass firepower tactics feasible. The training implications of American fighter tactics create additional challenges for German pilot development programs. Traditional German emphasis on individual pilot skill and energy management becomes less relevant when facing opponents who rely on overwhelming firepower and mutual support, rather than precision gunnery and tactical maneuvering. Pilot training curricula require fundamental revision to address new tactical realities. Fuel shortages that increasingly affect German training operations prevent adequate preparation for combat against American fighters. Student pilots receive minimal flight time in advanced trainers, while operational squadrons reduce training flights to conserve fuel for combat missions. This reduction in training quality creates a downward spiral, where inadequately prepared pilots suffer higher casualty rates against American opponents. The industrial capacity that enables American aircraft production extends to pilot training facilities that can process thousands of aviators simultaneously using standardized curricula and equipment. Flight training schools across the United States utilize mass production techniques to create competent pilots in much shorter time frames than traditional European apprenticeship methods. This systematic approach to pilot development provides the personnel needed to operate large fighter formations. Richter's experience illustrates the broader transformation of aerial warfare from an individual craft requiring years of training to an industrial process that can be systematized and scaled to unprecedented levels. The P-47 represents the successful application of American manufacturing philosophy to military aviation, creating weapons systems that maximize the effectiveness of available personnel rather than requiring exceptional individual capabilities. The symbolic significance of the 50 caliber machine gun extends beyond its technical specifications to represent American industrial abundance and democratic values. Each round fired by a P-47 embodies sophisticated manufacturing processes, quality control systems, and raw material abundance that reflect the broader American economic system. The ability to expend ammunition freely in combat situations demonstrates resource availability that German forces cannot match. American pilots learn to associate the sound and visual effects of 50 caliber guns with tactical effectiveness and mission success. The psychological confidence generated by overwhelming firepower enables aggressive tactics that would be impossible with limited ammunition aircraft. This confidence transforms individual pilot behavior and contributes to formation-level tactical advantages that multiply the effectiveness of American fighter operations. The mass production techniques used to manufacture P-47 ammunition create economies of scale that reduce unit costs while ensuring consistent quality and performance. Standardized manufacturing processes eliminate the variability that affects handcrafted ammunition, while automated inspection systems guarantee reliability under combat conditions. These industrial advantages enable American forces to maintain high ammunition expenditure rates throughout extended campaigns. Quality control systems implemented in American ammunition production ensure that each 50 caliber round meets precise specifications for ballistic performance, reliability, and safety. Statistical sampling and testing procedures identify defective ammunition before it reaches combat units, while feedback systems from operational experience drive continuous improvement in design and manufacturing processes. German ammunition production lacks comparable quality assurance capabilities due to resource constraints and production pressures. The research and development programs that created American ammunition technology represent institutional capabilities that German industry cannot duplicate given wartime constraints and resource limitations. Laboratory facilities, testing ranges, and engineering personnel required for advanced projectile development exceed German capacity, while the time needed for systematic development programs conflicts with immediate production requirements. Richter's recovery and debriefing contribute to German intelligence understanding of American fighter capabilities. But this information cannot reverse the industrial and resource advantages that created the P-47. Knowledge of enemy capabilities provides tactical advantages only when comparable resources exist for developing countermeasures. German industry lacks the capacity to match American fighter production while simultaneously maintaining existing programs and responding to other military requirements. The psychological transformation experienced by German pilots who encounter P-47 firepower affects morale and combat effectiveness throughout the Luftwaffe. Pilots who previously approached combat with confidence in their aircraft and training must now acknowledge that American fighters possess specific advantages that can overcome German tactical superiority. This recognition undermines the aggressive mindset essential for effective fighter operations. Squadron-level tactics within the Luftwaffe evolved to minimize exposure to American firepower while exploiting remaining German advantages. But these adaptations cannot address the fundamental disparity in resources and industrial capacity. Hit-and-run attacks that avoid prolonged engagements require fuel supplies for extended operations that are increasingly unavailable due to petroleum shortages and logistical difficulties. The training modifications needed to prepare German pilots for combat against American fighters require flight time and fuel allocations that exceed available resources. Advanced tactical training that emphasizes energy management and precision gunnery becomes less relevant when facing opponents who rely on overwhelming firepower rather than individual pilot skill. Curriculum changes that address new tactical realities cannot be implemented without adequate training resources. German aircraft maintenance operations face increasing difficulties obtaining spare parts and specialized materials needed to repair battle damage from 50 caliber projectiles. The heavy projectiles create structural damage that requires extensive repair work using materials that are increasingly scarce due to resource allocation priorities and supply line disruptions. Aircraft availability rates decline as repair times increase and parts shortages accumulate. The industrial bottlenecks that affect German fighter production become more significant as American bombing campaigns target manufacturing facilities and transportation infrastructure. Ball bearing production at Schweinfurt, which Richter was attempting to defend, represents a critical component in aircraft engine manufacturing that cannot be easily replaced or relocated. Successful Allied attacks on such facilities create cascading effects throughout German military production. Raw material shortages that increasingly constrain German aircraft production cannot be addressed through tactical modifications or training improvements. Aluminum, steel, and specialized alloys required for fighter construction must be allocated among competing military programs, while transportation difficulties prevent efficient distribution of available materials. These fundamental resource limitations cannot be overcome through operational or tactical solutions. The strategic bombing campaign that P-47s enable through their escort capabilities systematically targets German industrial capacity and infrastructure in ways that affect all aspects of military production. Transportation networks, power generation facilities, and manufacturing plants suffer cumulative damage that reduces German ability to produce and operate military equipment. The protection that P-47 provide to bomber formations multiplies the effectiveness of Allied strategic bombing. Fuel production and distribution systems that support German air operations face increasing attack from Allied bombers protected by P-47 escorts. Petroleum refineries, synthetic fuel plants, and transportation infrastructure suffer systematic destruction that reduces aviation fuel availability throughout the Luftwaffe. Operational capability declines as fuel shortages force reductions in training flights, combat missions, and aircraft ferry operations. The pilot replacement crisis that develops within the Luftwaffe reflects both increased combat losses against American fighters and reduced training capacity due to fuel shortages and instructor casualties. Experienced pilots like Richter who survive encounters with P-47 often suffer psychological trauma that affects their future combat effectiveness, while new pilot training cannot keep pace with operational losses. Richter's personal transformation following his encounter with American firepower illustrates the broader psychological impact on German military personnel who witnessed the industrial capabilities of their opponents. The realization that German technological superiority no longer guarantees tactical advantage undermines confidence in ultimate victory and affects individual performance throughout the military hierarchy. The tactical lessons learned from P-47 encounters spread throughout the Luftwaffe through formal intelligence briefings and informal pilot discussions. But this knowledge cannot be translated into effective countermeasures without adequate resources and industrial capacity. Understanding enemy capabilities provides advantages only when comparable resources exist for developing appropriate responses. German attempts to develop equivalent firepower capabilities for their own fighters encounter multiple technical and resource obstacles that prevent successful implementation. Structural modifications needed to accommodate additional guns affect aircraft performance characteristics, while increased ammunition requirements reduce fuel capacity and operational range. More fundamentally, German ammunition production cannot support the consumption rates that make mass firepower tactics feasible. The research and development programs needed to match American ammunition technology require institutional capabilities and resources that German industry cannot provide given wartime constraints and competing priorities. Laboratory facilities, testing equipment, and engineering personnel needed for advanced projectile development exceed available capacity, while the time required for systematic development conflicts with immediate production requirements. Manufacturing quality control systems that ensure American ammunition reliability and performance cannot be duplicated within German industrial facilities operating under wartime constraints and resource shortages. Statistical sampling procedures, automated inspection equipment, and standardized manufacturing processes require investments and expertise that are unavailable due to other military priorities and material limitations. The mass production techniques that enable American fighter and ammunition manufacture represent industrial capabilities that Germany cannot match given its resource base and strategic situation. Standardized manufacturing processes, automated assembly equipment, and quality control systems require initial investments and ongoing material supplies that exceed German capacity, while simultaneously maintaining existing production programs. Economic mobilization strategies that support American aircraft production involve resource allocation decisions and industrial coordination that democratic political systems can implement more effectively than authoritarian alternatives. Voluntary cooperation between government agencies, private industry, and labor organizations creates synergies that maximize production efficiency while maintaining product quality and technological advancement. The civilian economy integration that supports American military production enables resource allocation and manufacturing coordination that totalitarian systems cannot match despite theoretical advantages in central planning and resource control. Market mechanisms and voluntary cooperation create efficiencies that overcome the coordination problems inherent in command economies operating under wartime stress and resource constraints. Research and development capabilities that created American fighter and ammunition technologies reflect institutional advantages that extend beyond immediate military applications to include civilian research facilities, educational institutions, and industrial laboratories. The breadth and depth of American technological infrastructure cannot be duplicated by German institutions operating under wartime constraints and resource limitations. Personnel training systems that produce American pilots and maintenance technicians utilize educational resources and training facilities that represent massive investments in human capital development. The standardized curricula, training equipment, and instructor personnel needed for large-scale pilot production require institutional capabilities that German educational and military systems cannot match given resource constraints and competing priorities. The industrial base that supports American aircraft production encompasses raw material extraction, transportation networks, manufacturing facilities, and support services that represent decades of investment and development. This integrated industrial capability cannot be created quickly through government directive or resource reallocation, while wartime damage to German industrial infrastructure reduces existing capabilities rather than enabling expansion. Technological innovation that drives American aircraft and ammunition development reflects research traditions and institutional capabilities that extend far beyond immediate military requirements. University research programs, corporate laboratories, and government facilities create synergies that accelerate technological advancement while maintaining the broad industrial base needed for mass production and continuous improvement. The logistical systems that support American fighter operations overseas demonstrate transportation and supply capabilities that enable sustained operations at unprecedented scales and distances. Fuel, ammunition, spare parts, and replacement aircraft must be transported across oceanic distances while maintaining supply reliability that supports high operational tempos. German logistical capabilities cannot match these requirements given resource constraints and geographic limitations. Maintenance operations that keep American fighters operational require spare parts production, quality control systems, and technical training programs that represent significant investments in support infrastructure. The reliability and availability rates achieved by American aircraft reflect systematic approaches to maintenance and supply that German operations cannot duplicate given resource limitations and competing priorities. Communication systems that enable American fighter coordination and tactical control represent technological advantages that extend beyond radio equipment to include training programs, maintenance procedures, and operational doctrine. The tactical flexibility and mutual support demonstrated by P-47 formations require communication capabilities that German fighters cannot match due to equipment limitations and training deficiencies. The strategic implications of American fighter effectiveness extend beyond immediate tactical outcomes to affect German war planning and resource allocation decisions. Military leaders who previously counted on Luftwaffe interceptors to protect vital industrial targets must now plan for systematic Allied bombing that will reduce German production capacity and infrastructure capabilities. Economic planning within Germany must account for increasing Allied bombing effectiveness that threatens all aspects of industrial production and transportation infrastructure. The protection that P-47s provide to bomber formations multiplies the economic impact of strategic bombing, while reducing German ability to develop countermeasures or repair existing damage. Political leadership within Germany faces the reality that technological and industrial advantages once enjoyed by German forces have been overcome by Allied capabilities that continue to improve through systematic research and development programs. The psychological impact on civilian morale becomes significant as the population recognizes that German military forces can no longer guarantee protection against Allied attacks. Military doctrine throughout the German armed forces requires fundamental revision to address tactical realities created by American industrial capabilities and technological advancement. Traditional concepts of individual excellence and precision engineering become less relevant when facing opponents who achieve effectiveness through overwhelming resource advantages and systematic application of mass production techniques. The transformation of aerial warfare represented by the P-47 Thunderbolt illustrates broader changes in military technology and strategy that favor nations with superior industrial capacity and technological infrastructure. Individual pilot skill and aircraft performance characteristics become less important than production capability, resource availability, and systematic training programs that can create large numbers of competent aviators. Richter's experience above Schweinfurt becomes a symbol of Germany's broader strategic situation as the war progresses toward its inevitable conclusion. The industrial advantages that enabled American fighter development reflect economic and political systems that can mobilize resources more effectively than authoritarian alternatives, while maintaining the technological innovation and production quality needed for military effectiveness. The 8.50 caliber machine guns that destroyed Richter's aircraft represent more than firepower. They embody the democratic values and industrial capabilities that ultimately determine the war's outcome. Each round fired carries the accumulated expertise of American research institutions, the precision of mass production techniques, and the abundance of raw materials and energy that democratic societies can mobilize for military purposes. The sound of those 8 guns firing simultaneously becomes a recurring symbol throughout the remaining years of the European air war, heard by thousands of German pilots who discover that their technological and tactical advantages have been overcome by American industrial might. That distinctive sound, deeper and more sustained than anything in European fighter aviation, announces the arrival of a new era in warfare where abundance and systematic production triumph over individual excellence and precision craftsmanship. In the end, Richter's laughter at the ungainly appearance of the P-47 Thunderbolt transforms into profound respect for an aircraft that embodies everything his own Air Force lacks: unlimited ammunition, robust construction, powerful engines, and the industrial backing to produce them in overwhelming numbers. The fat machine that seemed so clumsy proves itself the perfect expression of American military philosophy, achieving victory not through elegance or efficiency, but through the systematic application of overwhelming force backed by inexhaustible resources. The tears that replace his laughter are not just for his own narrow escape from death, but for the recognition that his nation faces opponents whose industrial capabilities render traditional military virtues obsolete. In the thunderous roar of 8.50 caliber machine guns, Richter hears the sound of America's factories, the voice of democratic abundance, and the inevitable victory of nations that can transform their entire economies into instruments of war, while maintaining the freedom and innovation that make such transformation possible.